one person had a question from the mid-chapter review. So what page is that on, and tell me what number?
Miss, it's on page 33 and number 12.
Number 12. Yes, I'll get you one in a minute, okay? Okay, so it says here, so A or B, which one do you need? A, B is the one? No, A or B.
I already Miss, I already know the answer, but just the way that the answer is put in the textbook, I thought that when you state the equation of a tangent or a line, doesn't A always have to be positive?
Oh, yeah. Oh, yeah. Why they gave it in standard.
So the answer says yeah. Oh, so would we leave it in standard form with A positive? Because in the answers it says A is negative.
Oh, no, it's bad. Okay, hold on. I'm checking the answer.
Okay.
Thank you.
Okay. Thank you.
Proper standard form, A has to be positive. You will lose marks if A is not positive. Hold on.
Sorry for interruption.
Oh, for goodness sake. Unbelievable. 12A, in the chapter review the answers, it is showing an incorrect form of standard form. Okay, thank you so much for bringing that to my attention. I don't know how that's never come up before. Okay, so let me check. So that's 12.
Thank you.
Yeah, no problem. Thank you. Okay, so what I want to do, I'm going to go back. When did I assign the chapter review? Around 1.3 or 1.2? It would have been after 1.2. Or maybe I have it. I have it there? No, okay. Kind of fix it right here.
This doesn't matter if you do slope intercept or the standard form for equation of a line.
I'm going to tell you on the test which form I want. I could ask for either, so you have to know the rules to both, okay?
Okay, thanks.
All right, so actually I'm glad that came up because you need to know standard form. So let's review the rules for standard form. So for standard form, how do we do it? What are the rules for standard form? Okay, so ax plus by plus c equals 0. That's proper standard form. Okay, ax plus by plus c equals 0. A always has to be positive, always, always, always. You cannot have any decimals or fractions. A, B, and C must be integers. Okay, so no fractions, no decimals in standard form. Okay? Yes.
How would you find the equation of cycle?
What do you mean? Find the limit as h equals to 0, and then they give you an x value, you sub in that for x, and you do that value plus h, the formula.
Oh, this is formula?
Yeah, because, yeah, remember, in order to get an equation of a line, you need to know the slope. You need to know slope and y-intercept for y equals mx plus b, right? So once you have the slope, then you have a point, then you can find y equals mx plus b or standard form. You can find either form. Okay? I think I just something with the chat. I did not post it, Simon, yet. I will post it today. Okay? This handout right here, I will post it today. Okay? This is, it's just showing a little overview of what we learned. Okay? So see this? This is how we find our slope, right, of a tangent, right here, that formula right there. Okay? And here are limit properties. Good. Okay, continuity, average rate of change, instantaneous rate of change. This is pretty much a good little, what's it called, summary of chapter 1, right? Okay. Are there any questions from the review? Or from the homework? Could be from the homework as well. Any questions from the review or from the homework? So that's 1.5.
That's the review. Oh, I think, yeah, that's the review.
Page 46.
Yes, 46.
So it's 1.5. That's what I have to, page 46, 1.5, property dimension.
Yeah, properly. Next is economic review.
70. Okay. I'm just gonna check if I have it, if not, I'll do it. Okay? I have 7. Oh, you checked here?
Yeah, I checked.
Okay, so let's do it then, let's try it again. Okay, so, number 7. So 7B says, okay. So if I try to sub in x equals 0, I get 0 in the denominator, that's that. So I have to simplify. The ways that we taught about simplifying, one was conjugating. Yes? The other one was factoring. What do I need to do here? Yeah, you need to conjugate. Okay? Nothing to factor here. What gives it away? The radical sign, right? The root sign. So I have to multiply by the conjugate. Oops. You're not going. I know. I see. I got it. There you go. And we're always multiplying by 1, otherwise you're changing your equation, yes, or your expression. All right, so don't forget to write your limits. And now when you multiply, 2 times 2 is 4. And you would normally multiply through FOIL, right? But we don't have to here because the whole reason we're doing it is to get rid of that radical. The middle term will disappear. It'll be 0. Okay? And then I have minus 4 plus x. Don't forget the brackets here, because that's going to mess you up, right? Because it's a negative sign. And then I don't bother expanding this because I know it's going to cancel anyway. And so now 4 subtract 4 is 0. I distribute that negative. These cancel. I'm left with this, and now you put it. Now you take the limit.
How about, can you also do,
So here, if I sub in 4, I get 0, so I need to multiply by the conjugate. You tell me, what's the conjugate? So what problem did you have here? Where did you go wrong here?
I don't know, I think I did it with maybe my calculation.
Okay, so do it with me now. What would you do here? And?
Divide that by
Good. Notice here, I don't expand it. The whole reason I don't expand it, I've got now two binomials multiplied together. That's a binomial. I can simply cancel. And then you sub in. Okay, good. Excellent. Any other questions? What about from the review? Any questions from the review? No. Okay. So guys, as we spoke about yesterday, I moved the test to Monday. I'm so sorry. I know we did a poll. We said Tuesday, but that was under the assumption that our last lesson was today. I didn't realize we had this extra day. I don't know. For some reason, I started counting from Tuesday. I don't know why. And so we have a lot of time. So I'm going to keep the test for Monday. What I've done, if you go to the calendar, I put all the tentative dates for the test until Christmas break. Okay? So what you're going to notice is that you have one test every week. Okay? One test every week. The reason that I kept the test on Monday, because I'm going to be honest with you, for me it doesn't matter whether it's Monday or Tuesday. It's because I've been approached by quite a few students, and I know that they don't like the test when it's too far away from when you learn the chapter. And I don't blame you. I can appreciate that. So that's why I kept the test Monday and not Tuesday. It's because now we're getting a little bit too far away. We do have this extra day. You have the weekend. I think you have enough time to finish chapter 1. Okay? But I want you to take a look at all the test dates so that in your head you can plan and say, okay, so we started chapter 2. I need to have chapter 2 done by this date so that I have time to study for the chapter 2 test, which will be on this date. Okay, so I want you guys to start planning your time well. Okay, make sure that you leave yourself enough time. Don't leave it to the last minute. Okay, don't cram it all in the night before the test. Okay, you have a good indication now of when all your tests are happening. You should be able to plan well. Now, you're going to notice there's no chapter 5 test because that's going to be your CPT. So for the CPT, instead of having a chapter 5 test, we're going to have a CPT. So all of chapter 5 is going to be in that CPT. But I'm also going to include chapters 1, 2, 3, and 4 in there as well. So why? Why did I decide to do this? Chapter 5 is one of those chapters that brings everything together. So we're learning about derivatives, and we're learning it in stages. And chapter 5 is where we are graphing. So we're pulling everything that we learned from all those chapters, and we're putting it together in order to solve a graph. So chapter 5 is one of those chapters that is good for summing everything up. Okay? So I decided to do it this way, rather than give you a CPT at the end on vectors and calculus. I'm going to give you one on calculus, and then I'm going to give you another one on vectors. Okay? I thought that that would be better for you guys, and so that's what we're going to do. Okay? And because of timelines and for time reasons, I didn't want to give you a chapter 5 test and then a CPT right after it. It's just for timing, it doesn't really make sense. So we're going to put it all together. Okay? So just so you guys are clear on what exactly is going to happen. Now, keep in mind, these dates are flexible, right? They're always flexible. So what does that mean? Well, I don't know, something comes up and we miss a lesson because there's something that the school decides to do, and we don't get to do a lesson one day. So that might affect when the test is. And you guys might say, Miss, can we please do the test on the next day instead of, and we're gonna work with, we've gotta be flexible, right? So again, we'll do polls and we'll see, and we'll try to make everybody happy. But just so you have a general idea of when everything is happening. Okay, fair enough? Good,
Wait, Miss.
yes.
But why did we change the test to Monday?
Because I was under the assumption that we were finishing today. I didn't realize that I could start chapter 2 today. I didn't realize we had this extra day. So you're already getting the extra day. So technically your test should have been today. So instead of doing the test today, we're going to do it Monday. That's the extended day.
Oh, okay, I get it.
Yeah, for some reason, when I wrote it in my calendar, I started the semester Tuesday. I don't know why. I think it's because usually first day is, but anyways, whatever. Silly. That's what happens when you get old. Okay, so are there any questions?
Miss, for number 10 and 1.6,
Yeah,
can you just explain why we solve for the limit instead of subbing x for 3?
okay, let's see. Number 10 and 1.6. I'll have to look at it. 1.6, number 10. 1.6, number 10. Determine whether f of x equals, so if I just sub in 3, what's going to happen?
It becomes 0.
Yeah, it becomes 0. Now, the question is not asking you to take the limit. The question is asking you whether it's continuous or not. So what
Well,
you,
wouldn't we know if it's continuous or not if you sub in 3? And then it becomes 0. So
yeah, but we learned that in order to prove continuity, you got to show 3 steps. We learned that yesterday, right? Like in order for you to prove continuity, you have to first sub in 3, and then take the limit from each side, and then see if the third one satisfies. But I see what you're saying. You're saying as soon as you sub it in, the first one is not satisfied. That's what you're saying. Yes?
Yeah.
Yeah. You're right. You are right. You are going to see that it's discontinuous because number 1 is not satisfied. The only thing I'm going to say to you is, yeah, no, it's fine. It's fine. So what you're going to do is you're going to say condition 1, you're going to sub in 3, and then you're going to say, oh, number 1 is not satisfied, therefore the function is discontinuous at x equals 3. Done. One step. Yep.
All right, thank you.
Yeah, no problem.
Could we go through 5C on page 52?
Yeah. So 5C. Let's just give me 1 sec. Well, look at that. Okay, so 5C. So here we have this, yeah? Determine all values of x for which each function is continuous. Well, if you want to know where it's continuous, you got to figure out where it's not continuous. So what I'm going to do is I'm going to simplify by factoring out of that. And this is enough for me to see where my vertical asymptotes are. And we know that when you have a vertical asymptote, you have a point of discontinuity. So from here, I can see that when x is equal to 0 and when x is equal to 5, we've got 2 points of discontinuity. Now, this question is not asking you to prove continuity, so I don't have to go through steps 1, 2, and 3. They just want to know when it is continuous. Well, it's continuous everywhere else except for at these 2 values. Okay? I copied on the function. Yes, yes, I did. Okay, so we're going to say, therefore, so how would we define this? Well, it's x is an element of real numbers. It's continuous form. There you go. You're giving a little balloon. Okay. Cool?
When we determine a function's continuity, do we always solve algebraically or we just do the graph analysis?
Oh, it's up to you. That's up to you. So if I say to you, prove continuity, then you know that you have to use those 3 steps. So that means algebraically, you need to sub in, then you got to take the limits, right? If I'm asking you to prove continuity. But if you're looking to find continuity and you want to do a little sketch, you can. Now, let's be honest. If you have to sketch this, you're going to have to factor that denominator anyways, right? Like if you wanted to do a rough sketch here, you're going to have to find out what the asymptotes are. So you're going to have to factor out that x no matter what.
So when we do the check the 3 steps, that means we have to do it algebraically.
When I ask you to prove continuity, yes. This question is not asking to prove continuity.
Okay.
Okay? Yeah. You have to do those 3 steps, those 3 conditions, just like I did in class yesterday. Yeah. Any other questions, Dan?
For question 7, how come there's no hole?
Question 7. So why is there no hole? Probably because the functions don't go to the same place. And let's take a look. No hole. It's because they probably don't meet. So one will be open and one will be closed. You're talking about 1.6 number 7, right? Hello?
The one on the same page as question 5.
Yeah. Okay, so for number 7, look what's happening here. So when I go to graph this, let's just do a little sketch, just to understand what's going on. When x is less than 3, I have the function x minus 1. So that has a y-intercept of -1. And we're going up 1 over 1, but it's less than 3. Okay, and we're going all the way to 3. Now here, I have an open circle, correct? That's what's happening when x is less than 3. Whoops, I went to 4. 1, 2, 3. Okay? So that's what's happening there. Now when you have 5 minus x, now you have a y-intercept of 5. And you're going down 1 over 1. Down 1 over 1. Uh-oh, we should have. Oh, yeah, that's why we don't have hole. So look what's happening here. I have to do this in a different color for you to understand. The inside here, oops, sorry, I apologize. You gotta explain. Okay. Do you guys see how I get my graphs? You guys understand how I draw them? Right, and then I just erase whatever I don't need. Good. So this is what my graph looks like. The reason that there's no hole is because x is greater than or equal to 3 exists. Right there. Look, where x is equal to 3, we've got 5 minus x. Now we have this around it. There's no point there. So what does this mean? That means that when x is equal to 3, it only belongs to this function. Yes? But it does exist. It's there. So there's no hole. Not a hole. It does exist. Does that make sense?
Yeah, I kind of meant if we needed to draw the circle around the dot, because the textbook they didn't have a circle around the dot.
Yeah, technically it is correct to do the circle around the dot, technically, but it doesn't matter. You're not gonna lose marks if you don't. This function is continuous. Yeah, this function is continuous. The hole is filled by the other one because they meet, right? Cool? Any other questions? Yeah,
Someone just came into the meeting.
sorry, you gotta say that again. One more time.
I think someone joined late.
Oh, is this Blanca? Was that Blanca that just spoke to me? Let me access this.
Miss, it's the first tab.
Is this one? Oh, thank you. So, All right, guys, give me a second. I'm just gonna fix the appendix. Okay, are there any other questions? From the homework? No more questions. Okay, so we're gonna get started with chapter 2 then. Give me one second. Okay, so you'll notice that here we have the homework corrections for 1.6, and then after that, this is in 1.6. Okay, guys. I'll do this after. Okay, so I will post that review. I'm not going to post the summary, but I will post all the homework questions that were taken out. Okay? Fair enough? All right, looking at chapter 2. So we're still talking about limits. So now we're going to call them derivatives. We're going to call the slopes of our tangents by a different name. Does anyone need the handles, or do you guys have them printed? No, I don't. It's the only one that I can write. So I'm giving you whatever handles I would normally give to the class. Everything else is up to you. Okay? You need the handles, you have to do it. Okay. All right, so we're going to talk about the derivative function. And one thing that I'm going to say is, whatever we learn in chapter 2 today, you cannot use on your chapter 1 test. Okay, because we're going to be learning shortcuts to derivatives, and you cannot use the shortcut on the test. The test is all about doing it by first principles. Okay, which is important to know. So please take note of that. Okay, so we have the derivative function. Recall, given a function f of x, the slope of the tangent at a point a comma f of a is the limit as h approaches 0 of f of a plus h minus f of a over h. There's our formula for first principles. In chapter 1, that's how we found the slope of a tangent. This limit also represents the velocity or instantaneous rate of change of y with respect to x. So the slope of the tangent, if you're given a position function, so when given a position function and you find the slope of that tangent, you are finding velocity. Okay? So velocity is equal to the slope of the tangent when given the position function. Also finding the instantaneous rate of change. We've already talked about that. In calculus, this limit is called the derivative. Okay, we're finding the derivative of f of x at x equals a, denoted f prime of x. Okay, so here it's f. It kind of looks like an exponent of 1. It's not. It's more of a, not really an apostrophe either, but it's just like a little line, a superscript, little line, and we read it f prime of x. Okay? F prime of x equals the limit as h approaches 0 of f of x plus h minus f of x over h, provided that the limit is there. Well, if you look at this, doesn't this look very familiar? It's exactly that, but instead of showing a, they have x. The exact same thing. Okay? But instead of using a f of a, they're using x f of x. Makes no difference. Okay? Notice we are not substituting in a value for x. Instead, we are finding the slope function first. Then we sub in a specific value for x. Okay? So what does that mean? Well, in chapter 1, when we were finding our limit by first principles, what we were doing was subbing in that x value that we knew, right? And then doing that x value plus h minus whatever the y value was, and we went from there. Well, now we're going to be finding a slope function. And what a slope function is the slope. You can find the slope given the slope function at any point that you have. So you have this slope function, and then you want to know what the slope is when x is equal to 1. So you sub in x equals 1. And then you want to find out the slope when x is equal to 100. So then you sub in x equals 100. So the slope function is the slope of the function in general. And then you want to know what it is specifically at a certain point, then you sub it in. Okay? Whereas with you guys, when you were finding the slope of the tangent, you were finding it at a specific point. Okay? Example 1. Find the derivative of f of x equals x squared plus 3. So, notice it doesn't say at this point or at another point. They want to know the slope in general. So I say f prime of x equals, that's my derivative. The limit as h approaches 0, and I'm going to write out the formula. Which is the exact same formula we learned previously, but we're using x instead of a because we're not subbing in. So now, my function is x squared plus 3. So here, I don't want function notation now. I want to actually sub in. So I sub in x plus h. Normally, you would have subbed in a number plus h. And there's my y value. It's y2 minus y1. And we know it's just over h because they will cancel. The difference between the two is always h. Okay? And now we just expand and simplify. So expanding here, I get x squared plus xh plus xh, which is going to give me 2xh plus h squared plus 3. That's from my first bracket. And then I distribute the negative. The whole reason I have to do this is because I can't sub in 0, right? If I sub in 0, I get 0 in the denominator. All right. So now I look to see how this cleans up. So how does this clean up? What am I left with? I can see that. Cancel, cancel, and so I'm left with and now you should notice that an 8 factors out and you can simplify. Now we take the limit, which means I have to sub in 0. This is the slope of the tangent in general. So I can now find the slope at any point of my function. You want to know what it is when x equals 3? Sub in 3. You want to know what it is when x equals negative 25? Sub in negative 25, and you're going to find the slope at that point. Okay? So this is your slope function. Are there any questions so far? Okay. Well, now we want to know the slope when x is equal to 2. So look at the notation here. They want the derivative when x is equal to 2. Well, I have the derivative. The derivative is equal to 2x. That's my slope function. So we want to know the slope when x equals 2. So I just have to sub in. So therefore, the slope of the tangent at x equals 2 So we notice that our original function was a parabola. When I went to find the slope function, I noticed that it was linear. So what you should notice is that the degree always goes down by 1 when you take the derivative. Okay? So FYI, the slope function is always 1 order less than the original function. So if I had a cubic and I took the derivative, what would my derivative be? Yeah, the degree would be 2. Okay, good. Find the equation of the normal when x equals 2. Does anyone know what normal means? When we use the word normal, this is a word you're going to see a lot in this course. What does it mean, the normal? Good. Excellent. The word normal means perpendicular. Okay? Perpendicular. So, if this is my tangent here in red, then the normal means it's perpendicular to the tangent. So what should I do? So I found the slope of the tangent. We now want the slope of the normal, which we know is perpendicular to the tangent. What should I do? Yeah. Just flip. the negative reciprocal. Excellent. So if the slope is 4, then we know that the perpendicular slope will equal the negative reciprocal. So it will equal negative 1 over 4. So now I know the slope of the normal. They're asking for the equation of the normal. Do I have enough information to find the equation of the normal? So they want the equation of the line. The equation of the normal line. What do I do? But, so we can use a point. Which point would we use? Okay, we'd have to solve for it, yeah? Okay, so the first thing, we have a slope. We know now in order to get an equation of a line, we need to use a point. We need a slope and a point in order to come up with either y equals mx plus b or standard form. And we're going to do both. And I'm going to introduce to you another way to find standard form. Okay? All right, so we start with a point. I only have 2. But I can find y by subbing in 2. So I'm going to find f at 2. So when you sub 2 into that original equation, which is x squared plus 3, you have that. And s sounds right, it's 2 comma 7. So I have a point and I have a slope. So let's do this 2 ways. You guys normally do it y equals mx plus b. That's what you guys are used to. That's what you guys have always been taught. So let's do that first. What should I do? Excellent. Sub in the slope and the point, and then solve for b. Once you know m and b, you have your slope y intercept y. So 7 equals, the slope was negative 1 over 4 times 2 plus 2. And so 7 equals negative a half plus b. Bring it over to the other side. And you should be able to quickly see that we've got 14 plus 1 when you're finding a common denominator. And so b is equal to 15 over 2. Therefore, y equals there's my slope line. Method 1. Method 2. I'm going to show you what is called point slope. How many people have ever seen this formula? Has anyone ever seen this? Yeah, sorry. It is your slope equation solved. Yes, because we're just multiplying both sides. Good, excellent. We call this point slope. This is the point slope formula. And this is a good formula when you're looking for standard form. Okay? And you do the exact same thing. You just sub in. So my point is 2 comma 7. So now I have y minus 7 equals my slope times x minus 2. Can you guys see how this generates y equals mx plus b? Or excuse me, how it generates, well, it could generate y equals mx plus b as well. But can you see how it generates also your standard form? Okay, so here I have y minus 7. And what you can do is you can multiply everything by 4 also to get rid of your fraction. It all depends on what form you want, right? And then from here, you just solve. So if you want standard form, I'm going to go ahead and multiply everything by 4. Or you can actually solve it. It doesn't matter. Here, we'll do it standard form first, just so you can see that they're the same. So here I would have a half plus 7, which is plus 14 over 2. And so we still get the exact same equation. And you want this in standard form, we're just gonna multiply everything. And then from here, bring everything over to one side. Now, because I want x to be positive, I'm gonna go this way. And there's your standard form. And here's your. They're the same thing in two different forms. Take point slope. You're gonna see me use it a lot. Okay? I use point slope more so than y equals mx plus b. Are there any questions so far? So we found the slope of the perpendicular line, which is called the normal. How did we do that? Well, we first found the slope of the tangent, and then we took the negative reciprocal. We found the point that it's passing through by subbing in the x value, and then we found the equation of the line. Yes, please. Question? You're saying what we did last chapter. You're saying on this test coming up, you want to find the full function first and then sub in the I'm going to say stick to the methods that started class, right? We're there for a reason, right? So stick with just your first principles and sub in your x value, okay? For now. Because you're going to see that when I keep teaching you, I'm going to teach you a lot of things that are quick, right? But that's not the point of chapter 1, right? All right, example 2. Find the slope function, f prime of x, for this equation. So they're not asking for the slope at a certain point, they just want the slope function. So again, I'm finding my derivative. I know that it's the limit as h approaches 0 of f at x plus h minus f of x all over. Okay, so now we're subbing in. So you guys tell me, what am I going to have first here? What am I going to have to write there? You guys tell me. What should I write there? Beautiful. So 2, and here I have x plus h. That's my new x value, x plus h. And then just minus whatever your function is. Okay, what do I need to do next? I can't sub in 0. If I sub in my limit, I get 0 over 0. Not good. Good. We're going to do the conjugate. What is the conjugate to this? Good. Good morning. Yeah, no problem. I ran to the DCL. Probably just a double one. Okay, let's do it. What are we going to get here? Who wants to do it for me? Anybody at home want to try? Nobody? No, one person? Who wants to try? Anybody in class want to start doing this? Nice and loud, Lily. Good. Do I expend bottom? No. No. I'm just going to have to factor it out again. Okay, so what happens in my numerator? I ask again, what happens in my numerator? Yay, thank you. Who was that? Thank you for talking to me. Yeah, you can. Absolutely you can. I like that. So here in the denominator, we can factor the 2 out and then cancel it. And I think we should. Good, Jamie. And so now what I'm left with is 2. Now can I sub in? Am I ready to sub in?
Yeah.
Yeah. Now remember guys, when you're adding radicals, it's the same like adding like terms. So root x plus root x is 2 root x. Okay, so this is my slope function. Sorry? Oh, excuse me. Yes, we have to always reduce slope. Always. So normally, we know that this is not fully simplified because there's a radical in the denominator. For these purposes, you may leave it. You don't have to rationalize here. The point of this question is not put to simply, we don't need it rationalized. You can leave it like this, it's fine. Okay, you will not need marks. So what do we call this? What did we just find? Yeah, good, the derivative or the slope function. This tells me what the slope will be at any point. Do you notice anything about this slope function? There are values that x can't be. X has to be greater than? Good. X must be greater than 0. Good. Yeah, we cancel, and then when I happened to add these together, I was left with 2 x. And then I canceled the second. Okay? All right, that's your slope function. Part B. Oh. Find the equation of the tangent when x equals 9. So now what do? Yeah, just plug in 9. That's it. So what you want is your first derivative at 9. That's what you want. So that is the slope of the tangent at 9. Okay. So I have the slope. And now what do I need to do? I have the slope. What do I need to do? What else do I need to do to get an equation? Good. You got it. We need a point. To go any further, we need a point. You need a slope and a point in order to find b. Yes? Or in order to get your standard form. All right. So when I sub in 9, go back to the original. And sub in. And you'll see that you get 2, comma, right? I'm just subbing into the original function. which is 2 root x, or 2 root 9. So now I have a point, I have my slope. You guys are usually using y equals mx plus c, but I'm going to use my point slope. And so I have y minus 6 equals 1 over 3 times x minus 9. From here, I can multiply everything by 3. If I want standard form especially, yes. And then this is how we get our standard form nicely. X minus 3y, I have minus 9 plus 18. And so we simplify. And when you guys are writing your standard form, always on the left. Like this. Your extra line in the sheet should always be on. Not always, but I will ask again. That's correct. Because you're looking for the equation of that tangent, right? When you're finding a specific equation. So you have to use a specific slope. Are there any questions? So to find an equation, we find the slope. We got to get a point. Once you have a point and a slope, you can plug into your point. And maybe let's go here. Okay. Note, your derivative is this equation, right? Is this formula, provided the limit exists. There are cases where the limit does not exist. We know one of those cases. What's the one case we talked about where the derivative does not exist? We analyzed one special case where when we took the left-hand limit and when we took the right-hand limit, they did not equal. Which case was that? First? Yeah, we looked at one function and we saw that we had to be very careful with this one function because when I took the left-hand limit, square root function. So think about the square root function. The derivative, the limits do not exist at that starting point. You remember we always talked about a starting point? Well, if the limit doesn't exist, then the derivative cannot exist. Okay? Okay. So when doesn't the derivative exist? At a cusp. Do you guys remember what a cusp is? You learned it in MHS. Like this. Comes to a point. You see how it comes to a point? The derivative is undefined at that point. Okay? The reason for that is because think about it logically. If I needed to find the slope of this tangent there, what would my tangent be? It would be a vertical line. The slope of the tangent here would be a vertical line. What's the slope of a vertical line? Undefined. Okay, so this is y. Okay, undefined. So at a vertical cusp. Okay, so there you go, when the tangent is vertical. When a function is discontinuous, and I think for obvious reasons we can see why. If a function is discontinuous, then where's your tangent going to come? Where's your tangent going to go? We've got two different points. It's broken. Yeah? At a corner or abrupt change at a point. So let's think of another function that we haven't mentioned in this course yet. What's another function that has a point or an abrupt change? What's another function that has an abrupt change that you guys know of?
Absolute.
Yes, thank you. Absolute value function. The absolute value function comes to a point, just like a cusp does. And so it also has an undefined limit. there, so therefore the derivative does not exist at that middle point. Okay, where the two lines meet. Yeah? Good. Excellent. So, f of x is differentiable at point A if the derivative at that point A exists.
The requirement for the requirement that the derivative we only have
Okay, that's okay. You can print it will be posted. You can print it or copy it out. Okay? So f of x is differentiable at point A if the derivative of A exists. A function may be continuous at a point, but not differentiable. So just because it's continuous doesn't mean that you can take the derivative of that point. And we saw that with the absolute value function, with cost. These are all continuous functions, but they might not be differentiable. If a function is differentiable at a point, then it must be continuous. So what is this saying? Just because a function is continuous doesn't mean that it's differentiable at every single point. Doesn't mean that the slope is defined at every single point. But if you can take the derivative, if the slope is defined, automatically the function is continuous. Okay? All right, so here are all the examples. We've got a cusp. This is continuous but not differentiable. Here, let's take a look at this example of a function. Again, we have a vertical tangent here. And so therefore, the derivative is undefined at that point. We're going to be learning later on that that's going to be called a point of inflection. And it's not differentiable there, but it is continuous. Here, a discontinuous point. Again, I can't have a tangent there. Okay? I can't have a defined tangent unless it's vertical, touching both of those points. Okay, let's take a look here. Here's a parabola. It is a continuous function and it is differentiable everywhere. You can take the derivative of this parabola anywhere. Why? Because at this minimum value, at the vertex, I don't have a vertical tangent. I can draw a horizontal tangent. And that's okay. That just means the slope will be 0. Okay, good. Here is our absolute value function that we were talking about. Again, it is continuous, but not differentiable. Okay, why? Because of this sharp point right here. Right? So the tangent here would be a vertical line, not a horizontal line. Okay, and over here, this is continuous but not differentiable for obvious reasons. Is this even a function? Yeah, this is good. This is a relation. It's not a function. Very good. We know that because it doesn't pass the vertical line, right? Excellent. So if you want these examples, they're in your textbook as well. All of these graphs are in your textbook, so you can always refer back, or you are welcome to print them from my lesson, okay? Okay, so let's take a look at this example. And again, you guys don't have this. This is just me going over it with you. So, I have a step function here. Okay, so let's see what's happening here. I have negative 2x minus 7. Okay, so that's just a line that's going to be going downwards, right? Down and to the right. I know that because it has a negative slope. And it exists when x is less than or equal to negative 2. And here it is. I'll highlight it right here. That's the first portion. Okay? Then, when x is between negative 2 and 3, we have a parabola. Okay, and that's the parabola. It has a whole bunch of transformations. Whatever it is, here's the parabola. That's the second part of my graph. I don't think it's going to allow me to do a curve. Okay. Oh, there we go. Okay. Now, for my last part, it's just a horizontal line at 4.5. Yes, remember that's what that means. The function y equals 4.5. It's just a horizontal line going through 4.5. That's this part right here. So when I take the first derivative. Okay, what I want you guys to notice. When I take the first derivative, and I just did it quickly here, I was not expecting you guys to go and do it, okay? But I want to show you something. First of all, my linear function went to a constant y. What did we say? Yes. The exponent, when you take the derivative, the degree is always going to go down by 1. So a linear function has a degree of 1, so when I take the derivative, now it has a degree of 0. And anything to the exponent 0 is 1, so you're left with just a number. Yes? So it's a constant. Excellent. Now, my parabola, when I took the derivative, became linear. Good. Excellent. My constant, this is interesting. My constant has a degree of 0. But it doesn't now have a degree of -1, right? What happens is it just goes to 0. It becomes a horizontal line at 0. So when you take the derivative of a horizontal line, it's still a horizontal line, but now it moves to 0. Okay? All right, so I drew in the derivatives here. Okay? I drew in the derivatives. What I want you to notice here is at this abrupt change, do my graphs match up? Would my limit exist from the left and to the right? Would my limit exist as I approach this function from the left and from the right? Would that limit exist? No, the derivative. So the derivative is the green. So if I'm looking at the green line, which is my derivative, would this limit exist? No. The limits don't go to the same spot. They don't meet up. If the limit doesn't exist, can you have a derivative there? It is undifferentiable at that point. Okay? So this is now proving why we've made these conclusions. It's because the limit will not exist there. And what do we notice is happening here? An abrupt change in the actual function. Okay? Over here, again, an abrupt change. We're going from a parabola to linear. There's an abrupt change there. And when I go to take the derivative, would you say that the limits exist? Do they go to the same height? They do not. The limit does not exist. And so this is an example showing why at these points, so at an absolute value, or at other points, abrupt changes, why they're not different. The limit does not exist. You guys see that? And meanwhile, this function is continuous, isn't it? The original function is a continuous function, but because it has these abrupt changes, there are points where you cannot take the derivative. The derivative does not exist. Cool? So notice here the function is continuous, but not differentiable at x equals 2 and x equals 3, because the limit does not exist. It doesn't equal the same. The left-hand limit does not equal the right-hand. Good. Other derivative notations, and you're going to see me using these interchangeably. Okay? We have function notation, so f prime of x. We have xy notation, y prime. Okay? We have Leibniz notation, dy dx or d over dx. So what's the difference here? When you're using dy dx, it's the exact same as using f prime and y prime. When you use this guy, you have to write the function there. So what this means is you're taking the derivative, but the y is not there. Your function is not there. So you have to write in the function. I'm going to give you an example. If I have the function, something simple, y equals 2x. I go to take the derivative in this notation, I just go ahead and take the derivative. In this notation, again, I just go ahead and take the derivative. Here, but here, if I'm using this notation, I must now write the function. It's not there, there's no y. Do you see that? So this is the derivative of your function with respect to x. This is the derivative of y with respect to x. That's it. Are there any questions?
Miss,
Yeah,
can you explain the purpose of differentials?
what do you mean the purpose?
Like how would you use them for like a question or these questions?
The
Or can you
derivative?
just explain them?
So a derivative, so when we're taking the derivative, you're just finding a slope of a tangent. And so what you're basically doing is finding equations of slopes of tangents. That's all we're really doing. And that's all we're going to do. You just have to be aware that sometimes the derivative does not exist. That's all.
Oh, okay, thank
Yeah,
you.
that's all. No, it's nothing earth-shattering. It's nothing crazy. This course, the calculus course, we're just talking about slopes. Slopes of tangents and how they relate to curves. Okay, slopes of tangents and how they relate to curves. Cool?
Cool.
Cool. Good. And that's your homework for this session. So technically, this homework is not due till Tuesday. Yes? So this homework is not due till Tuesday. Just know that when you write your test on Monday, there might not be a lot of class time to actually complete this because we're writing the test, right? So just keep in mind that you're using a couple of work hours there. Okay? So maybe try to get started on it is what I'm trying to say. Okay? It's up to you. You guys are old enough to decide. Yeah. As soon as it's submitted, you may turn it off.
Because when it comes to Google,
You have to. And the thing is, okay, so we'll talk about all the, because now we've been through it and we've learned all the loopholes, and so we'll talk about that. Yes, you're fine. Yeah. Yeah, I'm gonna direct you, like I'm here. So I'm gonna say, okay, guys, everybody now turn your cameras on. We're doing the multiple choice question now, so your camera should be facing you. Doesn't have to be on your face, but it should be facing you. Yeah? No headphones are allowed while you're writing any test. There can be no headphones, and you're not allowed to have a phone anywhere near you. In your workstation, you're not allowed to use your phone as a calculator. You can use a calculator, not a graphing calculator. It has to only be a scientific calculator. And there should be no other technology other than your computer where you're printing from, or sometimes they do that to be printed in, and your calculator, pencil, ruler, that's it. So there should be, actually, you guys are using the book. So you guys can have your notebooks there. And you can have your notebook there, not textbook, your notebook. Right? What
Wait,
else?
Miss.
Yeah,
So no graphing calculators, right?
no graphing calculator.
Okay, thank you.
Yeah, no graphing technology. What else was I gonna say? I was gonna say something else. Okay. You'll notice that in the classroom, I put a test assignment there. The reason I put that test assignment there is because I want to make sure everybody knows how to submit properly. I don't want any problems. So I'm going to check today that everybody submitted properly. If you did not, I will let you know in one way or another, whether it's in class today or whether I email you, so look out for that. If there was an issue with the way you submitted, I will let you know. We must correct it before Monday. Now, you go to submit to me, and I don't know, you submit one page instead of two. Let's just say this happens. It's not like, I know this sounds bad, but you guys are old enough, you gotta make sure you're submitting the right work. So I can't have you come back to me an hour later, or 2 hours later, and say, oh, miss, I only submitted one page by accident. Well, I'm sorry, but too bad. Right? And I think for obvious reasons, you know why we have to do this. Right? So, make sure what you're submitting is correct. Make sure what you're submitting is visible. Look at the image that you're submitting before you submit it. Make sure it's clear. Right? Good. What else did I want to say? So the cameras are going to be on. So they're going to be on. You're going to submit your quiz. I see right away when you submit. Like I can check in my computer right away when you submit. As soon as you submit, you can't go back in. It allows one submission and one submission only. So at that point, once you submit, you just say, Miss, I submitted, I checked, you can turn your cameras off. Right? Okay. That's number one. When you say to me, Miss, I'm going to submit now, or I'm submitting now, At that point, I expect that submission to come in within 5 minutes. It doesn't take more. It doesn't take even less than 5 minutes to submit. I know, I do it all the time. So I expect that submission to come in. If that submission comes in 10 minutes later, 15 minutes later, I'm not going to accept it. Okay, everything's timestamped when you submit it, so I can check all the times when they've been submitted. So like I said, you're going to say to me, Miss, I'm going to submit now. I'm going to say, okay, and I expect that submission within 5 minutes. If I think it's too long, it's getting to a point where, wait a minute, this is taking way too long, it's a 0. So keep that in mind. Okay? Yes. Yeah, just a period. It's not even going to take the full. We're here 3 hours. It's not going to take 3 hours. But what does take time is the transition time. So we're going to all wait until everyone finishes the quiz, and then we're going to go to break, and then we'll say, okay, guys, now we're going to wait for this, go and print it, right? The printed. Yes, but remember, you have to make sure you change them to PDF. If it's not a PDF, I have a lot of difficulty marking. Okay? The problem is, it's not that I mind. I don't care. As long as I can see your paper, I'll mark it. The problem is that when they're pictures, I try to scroll to the bottom, and I have to zoom in. With the program that I use, it's small. If your full page comes in. So when I zoom in, it goes to the middle of your page. And then I try to scroll down to the bottom, and it doesn't allow me. It just zooms into that one part. So I lose work. So this is why it's very important that you submit as a PDF. Now, does that always happen? No, but it does happen. It's happened many times. Yeah. No, I want it as a PDF with the technology that I use is beautiful. It works beautifully. So PDF is perfect. Yeah. No, I'm okay. I'm good. My marking technology works beautifully with the PDF. I can mark all over it just without marking the text. It's perfect. Yes. So there's going to be 15 multiple choice. Okay. You're going to have 30 to 40 minutes to do it. I haven't decided on a time limit yet. I'm going to do it and I'll decide. Once you're done that, then we go do the written. Okay, everybody, print out your sheet. And again, cameras are on, right? Your cameras are on for your written. Now, the cameras are not pointed to your face. The cameras are pointed to your workstation. Yes? So either you give me an aerial view. I need to see what's around you. Everything that's around you. So if I need to see a clean desk. So all you have is the paper and your notebook, right? Your notebook. Okay. Look, everything is a picture of it. So this is why I told you guys about hand scanners. I'm going to see. I have a video from Ms. Lucy on how to use hand scanner. I will try to post that on. I had it on my last year classroom. I will try to get it to your classroom. You guys at least can watch the video. But I'm going to check today to see how many problems I have. Did everyone submit that assignment to me? Do it. Okay. Again, guys, if you have an iPhone, you can use the Notes app. By just touching the notes, it gives you the option to scan and change the PDF, upload it to your drive, and submit. Right? Yeah, if you have Android, Hand Scanner. Free app. It's wonderful. It works beautifully. Hand Scanner. Okay? Are there any questions? You guys at home, you're very quiet. You still with me?
Yeah, miss. Wait, is it just multiple choice? I'm so confused.
Regine, how many times? Part of it is multiple choice and part is written. You're going to do it separately. First, you're going to do the multiple choice. Once you're done, once everyone is done, it has a time limit. So once that time limit is done, I will then say, okay, guys, you're going to go print the test now. I will make it available to you and you will print it. Once everybody has a printed copy in front of them, we start. Okay? So when you print it, you just turn it over, leave it there until I say to start. Everybody starts together. When you're done, Miss, I'm done. I'm going to submit now. Yes? And you submit within a few minutes. Right? You submit it right away.
Okay.
Okay? And it's my discretion. So if I think that you've taken too long to submit, you may get a 0.
Wait, so how do How do I submit on iPhone?
So have you seen the assignment that I posted on the classroom?
Is it assignment?
Oh, boy. Go to the classroom.
Oh, it's the practice submission test?
You got it.
Yeah, what do I do with this?
Radine, last quadmester, how did you submit your work?
Well, I didn't have anything to write down. Like,
Okay. So you're gonna use, do you have an iPhone?
yeah.
Okay. So you are going to use the Notes app on your iPhone to turn your picture. So you're going to take a picture. Once you click on the Notes app, you're going to scan your document and it's going to turn it into a PDF. You're going to upload it to your Google Drive and then you're going to submit it to me. Go and try doing that now in that classroom assignment. The same way that you do it to the classroom is identical in G2L. There is no difference. Okay?
Okay.
Now,
Wait, you want me to do it now?
I think it's automatically linked. Mine's automatically linked. Yeah. Should be. If you're using your school account, well, you obviously are using your school account. It should be automatic. If your Google Drive is from your school account, it should be automatically linked. I don't know. I've never heard that, to be honest. Like, I've been doing this with my students all last term, and I've never heard that, not once. So maybe. I don't know. Yeah. No, so D2L, what I use for D2L is I go to YCDSP, D2L. I'll show you. Let's do it now quickly. I gotta do the next lesson. Let's just do this now quickly. Is there? Is there an actual app you can download? Okay, so I'm gonna show you what, that's great. I'm just gonna show you what I do. I use a desktop, right? So for me, it's different. I don't know. Even Classroom. I don't like the Classroom phone app. It doesn't show everything. I can't see the comments. I can't see a lot of stuff on the phone app that I can see on the desktop. But here, so if you notice, I saved mine right here. Under this, I've saved it, I've bookmarked it. But you just go to YCDSB D2L. Brings you here. E-learning on YCDSB. Once you're here, click on to log into virtual learning environment, which is D2L.